Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about inputs and outputs and how to evaluate functions. All right, x and y. So x and y are your ordered pair values. So remember, ordered pairs are in parenthesis x, comma, y, parenthesis. And x are your values that go side to side on your coordinate grid, and y are your values that go up and down on your coordinate grid. X is also your inputs, what you're going to plug into your function, your independent variables, and all your x values make up your domain of the function. Your y, sometimes called f of x, is your outputs, what you get out from the function, the dependent variable because it depends on what you plug in, and all of the y values make up your range of the function. Function notation uses f of x, and each input has a single output, okay? And the x values cannot repeat. So function notation, we have this example, f of x equals x squared. F is the function name. It doesn't always have to be f. It could be g, or it could be c for cost, or p for profit, okay? But it's f of x, or g of x, or c of x, depending on which variable you're using. Now, on the other examples, we have x's and y values. So this one, I have an x value going to two different y values. Well, each input, each x, has to have a single output. So this x is going to two different outputs. So that is not a function. All right, if I have different x's going to the same output, that's okay. So that one would be a function. All right, our first example. The Hamptons family had a fish tank holding 10,450 milliliters of water. The water is leaking at a rate of 270 milliliters per minute. Part A, define the input and output in the given scenario. Part B, write a function to model the situation. And Part C, how many liters of water will be left in the tank after 10 minutes? All right, well, M is going to be the number of minutes. And then F of M will be the amount of water left in the tank after m minutes. Okay, so m is my input, that's what I'm plugging in, and f of m is what I'm getting out, the amount of water that will be left. Write a function. So f of m, the amount of water that's going to be left in the tank after m minutes, I can get by doing 10,450, the amount of water I started with, minus 270 per minute, so times m. Okay, I'm subtracting because it's leaking, so it's coming out. How many liters of water will be left in the tank after 10 minutes? Well, all of these calculations, this function is going to give me milliliters. So then I'm going to have to convert. So I'm going to do f of 10 for 10 minutes. I'm going to plug 10 in everywhere I see an m. And I'm going to do 270 times 10, which gives me 2,700. I'm going to subtract that from 10,450, and I get 7,750 milliliters. But they want the answer in liters. So I know that there's 1,000 milliliters in a liter. And if you don't believe me, you can ask Siri or Google. Okay, so I'm going to divide by 1,000. Or you can just move your decimal 3 places to the left. All right, the volume of a cylinder, V of h, is given by the area of the base times its height, h. The radius of the base of the cylinder shown to the right is 5 inches. The cylinder volume is equal to pi r squared h. Write the function v of h that represents the volume of the cylinder. So I know that the volume comes from pi r squared h. So v of h is going to be pi, which is 3.14, times my radius squared. Well, they told me the radius was 5, so 5 squared times the height, which is unknown. 5 squared is 5 times 5, which makes 25. So now I have 3.14 times 25 times h. 3.14 times 25 gives me 78.5. So the volume, depending on the height, is equal to 78.5 times the height. So there's my function rule. Now it says find v of 3 and tell what it represents. Well, I'm going to plug 3 in everywhere that there was an h. Well, h stood for height. So I'm plugging 3 in for the height. So that must mean the height is 3 inches. And when I multiply 78.5 times 3, I get 235.5 inches. So that means the volume of the cylinder with a height of 3 inches equals 235.5 inches cubed. All right, which of the following relations is not a function? Remember, to be a function, your x values cannot be repeated. So I'm going to look at the x values in all these ordered pairs. 0, 2, 5, 3 in the first set. None of those got repeated. For B, I have 4, -4, and 0. No repeats. For C, I have 6, 4, -3, and 4. Well, the 4 got repeated, so C is not a function. All right, consider the following relation. So a relation is just a set of ordered pairs. Which ordered pair could be removed so that the relation is a function? Well, I have an ordered pair 3, 8, and I have an ordered pair 3, 11. They both are using the same x value. So I could get rid of either one, either 3, 11 or 3, 8 could be removed, and then that would be a function.